Welcome to a lesson with Dr. Powell. Let's take a look at a way that we can find the minimal polynomial of a square matrix A. This is the smallest degree polynomial such that when you plug in this matrix A for x, we're going to get out the zero matrix. So what we do is we look at a zero action matrix. Zero action because this is described as the difference between two actions that are the same. We're assuming that x itself acts as the matrix A, but also it's acting like a scalar. So like a scalar matrix, but we're saying the scalar matrix behaves the same way as A, which means that this acts like zero. And we're thinking of this action by multiplying by column vectors on the right. So the output of that process will give you a zero vector. And now the output of such a process, thinking of that way, always comes as a linear combination of columns, meaning these columns are actually all represent the zero vector. Now, if we want to maintain that idea of outputting the zero vector, then we can precompose this action, thinking of it as a function, with column operations, which are polynomial isomorphisms here, and we'll still be getting out zero vectors. Okay, so we're going to be doing some column operations, and we'll talk about the strategy that we use. Now we're going to work until we get to a point where the columns, if we look at the columns and we take the greatest common factor of the entries in each individual column separately, and we gather those. So the first one is x minus 2, 1 basically is the polynomial that can divide all those. 1, and then this guy is actually, you can factor that as x minus 2 quantities squared. You look at all these and you add up the degrees, degree 1, degree 0, degree 2, and you get 3. When you get 3, which is the degree of this, this is a 3 by 3 matrix, then we'll stop. And the minimal polynomial is actually ends up being the least common multiple of these guys, which in this case is simply just x minus 2 quantities squared. So we have thus obtained the minimal polynomial of this, the minimal polynomial of this matrix A. So we want to be able to get to this point so we can make that determination right here. Now, to kind of give us some motivation for what's kind of happening as we're going along through this process, this vector, whatever it is already the zero vector. This vector, we know that x minus 2 times, so 1, 0, 0 is actually the zero vector. And this one, you know that x squared minus 2 quantity squared times 0, 1, 0 is the zero vector. Now, if you take a look at what these guys actually look like this is, take a look at, you see this vector 1, 0, 0, and then, so we take this vector, this is a subspace of R3, and then this guy right here, but what we're going to do, we're going to be looking at some spans of these guys. We're going to be looking at Rx spans, so polynomial spans of these vectors. All right, so let's take a look at some polynomial spans of these vectors. We'll actually notice that the polynomial span of this and of that together give us all of R3. And because of that, x minus 2 is kind of acting like the minimal polynomial right on this guy. And this guy's acting like the minimal polynomial on that guy. And together, it actually means that the least common multiple of those two guys is a minimal polynomial overall. Just as a kind of a quick intuitive explanation for what we're doing. Now, if we take a look at what these spans are, like what is this span? It actually ends up just being the regular R span of that guy. Now, the span of this one right here, what does that end up being? It ends up being this. So 0, 1, 0, and negative 1, 4, 1, which has dimension 2 here. And together we actually get a span of the whole entire space, R3. How do we determine this? Well, it's kind of nice because if the polynomial that minimally acts like 0 on a vector is degree 1, then you always end up getting this. If it's degree 2, you always end up getting this. You always go like 1 less, like here than there. Because if you went further, let's think, if you went further, like if you went x squared, 0, 1, 0, well, let's see. Well, you know that x minus 2 quantities squared times 0, 1, 0 is actually equal to the 0 vector. So let's think about that for a minute. So this is x squared minus 4x plus 4 like we had over there. And so that means that x squared is actually behaving like, so think of this as being like 0. That means x squared is kind of like 4x minus 4. Oh my goodness. So you can erase this and think of 4x minus 4. So really you only have up to degree 1 ever acting on things if you have this type of situation occurring. So really this is the whole span right there. So we really truly get if those degrees add up to 3, these guys, the polynomials that we found are actually the minimal polynomials on those things, and those actually give us degrees. These bases are actually linearly independent, and that's enough, and it'll guarantee that it's the minimum polynomial overall if we just take the least common multiple of those guys. So little quick intuitive explanation, and that's enough. So again, kind of going over what the method is. We create this zero action matrix. We do some column operations until we get to a point where we can take greatest common factor of things, and we notice that that the degrees of those guys add up to 3, or to the number of, if it's an n by n matrix, to n. And then we just take the least common multiple of those greatest common factors, and we got the minimal polynomial. Now, kind of some strategy. How do we get to this point? Well, kind of at each step, we try to create a new row to have all 0 entries but 1 if possible. If we have to use, going back and forth using something called the Euclidean algorithm, I guess we suppose we could in more challenging situations, in order to arrive at to make one of the entries in a row a greatest common factor of everything in that row, and then use that to kind of pick out the other ones. We could do that. Here, this is a very simple case, though, where in this row right here, we have, we can make that a 0 just by doing what I call an airdropping. Take a multiple of that guy and pop it over there, make a 0. So we have that. Now we look at what's left over. We can kind of cross out what we've done so far, look at what's left, and we kind of think of the same rule of thumb. Try to get something else to be, try to make a row that currently, in what I see, doesn't have a, in what I see, if it currently doesn't have only one non-zero entry, try to make another row be like that. So this one already, it works like 0 that, so we're going to work with the other one. And we can do that by doing an airdrop over this way, as I have illustrated to get to that point. Now, why don't we stop here? Well, if you look at this, the greatest common factor of this column is x minus 2, 1, x minus 2. That's degree 1, 0, 1. That doesn't add up to 3, so we can't stop here. So that's why we keep going. Okay, well, that kind of sums up this little example of finding the minimal polynomial. Thanks for watching.